Hello guys, welcome back to my channel SK's Physics, and today we'll discuss about electrostatics of conductor. The process of electrostatic induction of a conductor, there is no external electric field. Now when we applied electric field inside the conductor, electron moves and induce the electric field inside opposite direction. So the total electric field is 0. The field is uniform before the metal sphere is put in. Now after the metal sphere is put in, there is electric field. Now some important results regarding electrostatics of conductor. Here the first result is, inside a conductor, electrostatic field is 0. Consider a conductor neutral or charged. There may be also an external electric field E0. A conductor has free electrons as long as electric field is not 0. The free charge carriers would experience force and drift. The charge is free electrons drifts toward the positive plate because negative attracts from positive plate and plate leaving the positive core behind. Same as positive attract towards negative plate. In the static situation, the free charges have so distributed. So electric field is in opposite direction in inside. The electric field is 0 everywhere inside. So electrostatic field is 0 inside the conductor. So E net is equal to 0. The second result is, at the surface of a charged conductor, electrostatic field must be normal to the surface at every point. If E were not normal to the surface, it would have some non-zero component along the surface. A free charges on the surface of the conductor would then experience the force O. Here the theta, that means a component is E cos theta, that is non-zero component. In the static situation, E should have no tangential component. Thus, electrostatic field at the surface of the charged conductor must be normal to the surface at every point. For a conductor without any surface charge density, field is 0 even at the surface. So E is equal to 0 is only possible when theta is equal to 90 degree because cos 90 is equal to 0. So theta must be 90 degree. The interior of a conductor can have no excess charge in the static situation. A neutral conductor has equal amount of positive and negative charges in every small amount of the surface element. There is positive and negative charges. When the conductor is charged, the excess charge can reside only on the surface in the static situation. This follows from the Gauss law. Consider any arbitrary volume element V inside a conductor. On the closed surface S bounding the volume element V, electrostatic field is 0. Thus, the total electric flux through the S surface element is 0. Hence, by Gauss law, there is no net charge enclosed by S. That means Q is equal to 0 inside. Flux is equal to integration E dot ds is equal to Q upon epsilon 0. Now here Q is equal to 0, so flux is equal to 0. Hence, there is no net charge at any point inside the conductor, and any excess charge must reside the surface. Fourth result, electrostatic potential is constant throughout the volume of the conductor and has the same value as inside on its surface. Since E is equal to 0 inside, the conductor has no tangential component on the surface. No work is done in moving a small test charge within the conductor and on its surface. There is no potential difference between any 2 points inside or on the surface of the conductor. So the potential difference is 0. The dV is equal to minus E dot dr. Since E is equal to 0 in the interior of the conductor, therefore dV is equal to 0. That means V is equal to constant. In the system of the conductor of arbitrary size, shape, charge configuration, each conductor is characterized by a constant value of potential. But this constant may differ from one conductor to other conductor. That means surface charge distribution may be different at different points. Now here for some charge configuration. Every conductor is an equipotential volume in 3-dimensional. We know that sigma is equal to Q by S. So for small surface area, that is sigma maximum and sigma minimum for big area element. Fifth result, electric field at the surface of charged conductor is E is equal to sigma upon epsilon 0 into n cap. Choose a pillbox, a short cylinder, as the Gaussian surface about any point P on the surface. The pillbox is partially inside and partly outside the surface of the conductor. It has a small area of cross section delta S and negligible height. Just inside the surface, the electrostatic field is 0. Just outside the field is normal to the surface with magnitude E. Thus, the contribution to the total flux through the pillbox comes only from the outside circular cross section of the pillbox. The charge enclosed by the pillbox is Q is equal to sigma delta S. Sigma is equal to Q by S, so Q is equal to sigma delta S. Now, by Gauss law, flux is equal to E dot ds. So we can write as E dot delta S is equal to Q by epsilon 0. So Q is equal to sigma delta S implies E delta S is equal to sigma upon epsilon 0 delta S. So therefore E is equal to sigma upon epsilon 0. we get the vector relation which is true for both the signs of sigma. For sigma is greater than 0, electric field is normal to the surface outward. For sigma is less than 0, electric field is normal to the surface inward direction. Sixth result, electrostatic shielding. What is electrostatic shielding? Here a rabbit and electric source. If rabbit is in a metal cage, the metal cage protects the rabbit from electric effect. That means cage is being as a shield, that is electrostatic shielding. And the rabbit is unharmed, so we protect the rabbit. Electrostatic shielding, here a theory. Consider a conductor with a cavity with no charge inside the cavity. The electric field inside the cavity is 0. So E is equal to 0 inside the cavity. The proof of the result for the shell makes use the spherical symmetry of the shell. The vanishing of electric field in the charge-free cavity of a conductor E is equal to 0. So flux is equal to 0. So E dot delta S is equal to 0. That means sigma Qi is equal to 0. That means inside the cavity there is charge free. That means no charge. If the conductor is charged or charges are induced on the neutral conductor by an external field, that means there is negative and positive charges. All charges reside only on the outer surface of a conductor with cavity. Whatever be the charge and field configuration outside, any cavity in a conductor remains shielded from outside electric influence. That means the field inside the cavity is always 0. This is known as electrostatic shielding. The effect can be made use of in protecting sensitive instruments from outside electrical influence. A conductor shell can shield the external field like this. Thank you for watching.